Welcome to the Naavik Gaming Podcast, where it is our mission to explore the business and future of video games. We bring together the industry's brightest builders, investors, and thinkers to keep a pulse on current events, dissect emerging trends in games, share lessons learned, and have a great time. This podcast is also part of Naavik's growing ecosystem, which ranges from free and premium research to consulting and advisory services. For more information, visit www.naavik.co. This episode is brought to you by Heroic Labs, which powers some of the world's biggest games with its Heroic game stack. Its composable products are Nakama, the open source backend game server, Hero, the game development framework for all your live service game features, including the complexity of managing offline mode, Satori, the world-class live ops product for maximizing monetization and retention, and lastly, the Heroic Cloud to provide massive scalability. After nearly 10 years of operation, thousands of studios trust Heroic Labs to help them focus on their games and not worry about game tech or scaling for success. To learn more and reach out, make sure to visit heroiclabs.com or check out the link in the show notes. This episode is brought to you by Neon. For the first time in our industry, developers can finally have their own D2C channels to save on App Store fees and build closer relationships with players. But there's a catch. Selling direct means either building complex infrastructure yourself or choosing among legacy providers whose inexperience in games or questionable reputations pose real risk to your business. Luckily, there's Neon, the D2C platform built for games. As a merchant of record with customizable web shops optimized for conversion and modern APIs that let you use your existing LiveOps tools, Neon is trusted by some of the biggest names in gaming to help you sell direct without the typical overhead. To start selling direct and finally take control over your full player experience, simply head to neonpay.com or check out the link in the show notes. And with that, let's jump into the episode.
Hello, everyone. I'm your host, Devin Becker, and today I'm delighted to be joined by Christoffer Holmgård, CTO and co-founder of Modl.ai, and Julian and Togelius, professor of computer science and engineering at NYU and co-founder of Modl.ai. Modl.ai uses AI to help improve the QA process for gamers, quality assurance, if you're not familiar with the acronym. Today, we're going to discuss the realities of the QA and AI market. And for those who didn't hear the previous episode that we recorded last year, could you give us a quick overview of what Modl.ai does in your background, Christoffer?
Oh, yeah, sure. Absolutely. So Modl.ai is entirely focused on helping game developers automate and augment their QA processes and their QA teams. So what the company does is that we apply AI to player games. We apply AI to look at what happens when these AI agents are playing the games, and then identify, issues or areas of concern that you would want to lift up to your QA team, so that somebody can do something about it. And once those QA specialists and managers have had a look at it, decide what goes on to the rest of the development team, and ultimately helping people do more in terms of improving the quality of the game to the benefit of their players. And we've been doing that for quite a while. We got started in this space in 2020, and then in recent years we've started taking a slightly different approach to how we do it, because as people might have noticed, how AI works and the meaning of AI has changed a lot over the last 5 years.
Cool. And your background and involvement in Modl.ai, Julian?
So I've been doing. I came to this from academia, and I'm still large in academia. I've been doing research on AI for video games since way before it was cool, really. I mean, starting like more than 20 years ago. And back then, people did not take it serious at all. You're doing what? You're doing neural networks for like car racing and platformers and stuff like this. Like, why would anyone want that? That's not real science. I used to get asked like, oh, that's fun, but what's your real research? And then I'm like, this is my real research. Oh, and then look at me like, oh man, this guy is never going to have a career. Well, jokes on them. So, later on, I was part of the founding team of Modl.ai together with Christoffer and several others. And we were looking into, because we came from a disparate set of backgrounds, including game design and AI, and a couple of other things. And we had a lot of experience in in this. We wanted to bring modern AI to video games, and we were looking for what are the problems we can solve, and we pretty quickly zeroed in on, yes, quality assurance is the thing, because partly because it's a problem people want solved. People are generally fine with speeding up quality assurance, and it's like there's a lot of low value testing tasks that people don't necessarily want to do. So we decided that, which is as opposite to, for example, character art and so on, where it's much more ethically tricky. So we decided this is what we're going to go for. And yeah, as we'll give a little bit of an overview, we tried a bunch of things to make this work, and we've learned a lot along the way. And I think we have something really quite cool now. Finally, after many learnings along the way.
Cool. Well, it's been a little over a year since you guys were last on. I think in spring of last year, and we'll link to that appearance in the show notes as well, just to make sure people can catch up on a little bit more detail on the QA process you talked about. But I wanted to kind of catch up on, since the last time you were on, Christoffer, what are some of the biggest ways that AI, in generative AI specifically, has changed and affected the product of Modl.ai? Just catch us up on what's gone, especially since it's been kind of a big last year, I think, for AI.
Yeah, definitely. So in the last year, and obviously, you could see a lot of things ramping up to that until it happened. But definitely in the last kind of 12 or 18 months, we think that it's become really visible that we could use generative AI to achieve something that we actually talked about all the way back when we started the company, but that we never attempted because we didn't think it would be technically feasible. And what that is to do what we would call, what we call black box testing, or completely, non-integrated testing of video games. And so what that means is that, the major thing that we've seen enabled by generative AI is that it has enabled us to take images from games and then use those images to make decisions over what to do in the game. Now, but if you went back a couple of years ago, our products and everything we did was based on integrating very tightly into the game engine. And you get a bunch of benefits out of it. You get kind of direct X-ray vision into what's happening inside of the game. Or, if we think about it from sort of the self-driving car metaphor perspective, it's kind of like having a super advanced LiDAR system, and you can, measure everything that's happening. That makes it really easy to be, or at least easier to be an AI that has to play a game. But it also means that you have to invest a lot of time in, putting this software integration into the game, getting these values out. You have to think a lot about, all these different parts of it. Now, what we started doing in the last year was that we decided to take the route where we said, well, what if you didn't have to do any of that kind of engineering and integration work at all? What if we could just play the game from the screen the way that a human player does? And what if we could just send our input to the game using the same inputs that a player does, or simulated versions thereof? And we'd been wanting to do that since probably at least 2019, and probably earlier, Julian, in the research domain, right?
I recently came across a web page from my days as a postdoc back in 2008 or so, where I was like, hey, I'm working on this thing, trying to play first-person shooter games on pixels and so on. And it is true that I was working on it. It is not true that I made any progress.
That's right. But I mean, well, some progress was made. But I mean, around last year, 2024, I just think it became very evident that this suddenly, the LLMs and the VLMs were big enough, they were precise enough, and there was enough capability in there that you could extract information out of the systems that we just didn't consider that realistic before. And the other side of it, the other thing that generative AI has enabled us to do with the product that we have now is that it enables our users to kind of talk directly to the AI agents in terms of what they should be doing when we're testing the game, or in our case, writing it, to be honest. But we could add a voice feature at some point. I don't know. But what it means is, previously we would have interfaces and custom things that we had built to allow either a developer or an SDET or the QA person to tell the AI agent what to do. And the way that our solution works now, you write it in plain English, until we support other languages, I suppose, English for now. But so you write in plain English what you want to happen in the game, and that's kind of like also a major change in how we've been approaching this product for the last 12 to 16 months.
It's like, when we started this, 2019, 2020, the stuff we're doing now couldn't have been done there. And then there wasn't the technology to build on. And in fact, the technology, it probably wouldn't have been possible even 2 years ago, maybe 1 year ago, So we're kind of, right now, the way we're building the product, we're riding on the frontier of foundation models. It sounded really good, didn't it? Should put it on an ad somewhere. But the good thing about this is that product would only get better, but it's also clear that it could not have been done. We should have asked the investors for an 8-year runway originally, right?
That would have been perfect timing. But better late than never. But I also think from a product perspective, but now we talked a little bit about the technical parts of things and the motivations and all that. One of the things that you gain when you have a black box testing solution and something that can, play the game just by looking at it, take instructions just in English, is that you broaden the range of people who can contribute to that, to that process of automation in game development. And so suddenly this is not necessarily just for remit of game programmers and engineers and people who can have direct access to the code base. Suddenly you have a much wider range of people who can start automating what happens in the game production process, and they all bring different expertises into that. They can contribute in different ways, and so that's something that's really exciting to us as well, that we can bring it to more people.
Well, it's cool that you guys are able to make that shift, because it's obviously when it's a QA tester testing the game or a player playing the game, they're not integrated into the code. And they don't interact through the code. They watch the game, they input the controls and things like that. So you're doing, it sounds like, a better job now actually simulating the end user, and that, I would imagine, can result in a better QA process. Obviously, not exactly the same, but definitely something that better mirrors either a QA tester or a player. But speaking of those changes, looking back, Julian, you were talking about some of the things that made progress that didn't. What assumptions from the sort of previous generation, maybe prior to last year, or going through the last year, assumptions from that sort of previous era of AI before the generative LLM stuff got really good, turn out to kind of be wrong, and which turned out to be correct, especially the stuff that you've benefited from, or the hurdles you kind of had to overcome to get here?
So basically, within Modl, we've tried 100 ways of doing this. And outside of the Modl, we've in academic community tried 1,000 ways to play games in general. And I often, when I sum this up, we are on our second edition of an AI in games book, by me and Jorgis Yanakakis, who's also involved in the company. We basically catalog the different ways you could use AI to play a game, and it turns out it differs completely depending on the characteristics of the game and the characteristics of what you have access to. What is the information you have access to? Do you have full state information? How is it represented? Is it pixels? Is it objects? Is it simulated sensors? Do you have a forward model so you can simulate things? And all these things, there are much easier and much harder ways of doing this thing. And if you have a simulator, it's like a forward model of the game, then things are way easier. So the chess really is the paradigmatic, simplest possible case. You have full information. You have a discrete game state that is easily processable, just a few bytes. A fast forward model, you can simulate millions of moves, all of these things. Modern games is not like that. You don't have that. You can't simulate the engine that fast. The core loop is kind of it intermingles with UI elements and all kinds of stuff. And it's not even really well defined what the game state is. There's a whole list of things that make it hard. So for a long time, we tried various things of looking at, how could you make an integration that integrates an engine, even supposing that you don't have a forward simulator, just gets structured information about the game in a way that is useful for a model or a search algorithm trying to play the game. And this turned out to be really, really hard, because one thing is, it's one learning we've had again and again and again, is that all games are different. And not only are they different, they're different in different ways. It's often sometimes subtle things with the mechanics and even like how the UI plays into the to the game loop and so on really throws you off. So in a sense, what we're doing here is just like we're like, this is the Gordian knot approach we're taking here of just basically like, nope, skip all of that and basically just work from pixels. So I think a lot of the learnings we have about like what kind of information we need, they still apply. You need certain other information in a first-person shooter than you need for a matching tile game, for example. But we are not building those sensors because it's just too expensive to do for each game. We really learned the hard way that you can't spend like tens of thousands of euros of integration on each game. It doesn't work that way. But we do have a lot of learnings that we brought with us, including how different game genres have very different kind of affordances and things that are important to look at. And these things scale, like, matching tile games do behave similarly in different ways in terms of what information you need and what and at what kind of scale of time you need to operate and so on. And that differs a lot from first-person shooters, for example. And sometimes you see people coming new to this field and basically, we can have one model that works for both of these. And I'm like, sure, try that. Call me when you're done. Tell me how it went.
So, I mean, something that I'm really curious about, you mentioned, different genres and different affordances, things like that. And you like the customer's not having to directly integrate the game into the code. Are they still having to explain to the AI how the game works? Like what kind of prep work do they have to do? And also, how do you handle those genres that are maybe brand new or mashups of genres where the AI may not have any preconceived notions of how to play it? Like, I imagine the AI like basically understands the first person shooter and how that works, and genres that have been around for some time that may be trained in the model, at least in like conceptual understanding. How do they handle this is new stuff? Like we're gonna have to explain to you, AI, how this game works so you could test it.
Yeah, I mean, concretely, the way that we do it, maybe the place to start is that at the moment we're trying to be pretty specific about what kinds of games would we support, not really based on like how much information is available on the internet about them. It turns out that for most game genres, unless it's like super novel, there's usually some information out there that will have been crawled by the frontier models that they can talk about, at least at the high level. But you got to think about like all components of the system and kind of like the speed of how quickly some of these models can make decisions inside of games in a cost-effective manner. And so for that reason, we've been spending this year mostly with mobile casual games. And they're super interesting to work on because they are, if you don't play them, they are more complex than you'd often think. And they require sort of like some thinking ahead and a good amount of reasoning. And a lot of them don't require you to have, Twitch level capabilities in terms when you're of playing the game. You can take a little bit of time to make a decision. Or even if there's some real-time aspect to it, you might be able to plan a number of steps ahead and then still buy yourself some time for the whole system to think. So that's kind of like one way that we've been addressing this, and now we're scaling it to other game genres and moving in other directions. But that's where we've started. I would also say that the other way that we handle kind of like differences and complexities is that we provide the AI models, both the big ones that we can only get, from large server farms, but also some that we set up ourselves. We provide them with, specific context about the game in question and descriptions about the game. So you provide a little description about, what is this game? What is this about? We might help the customer do that as well if they want us to. But it really is all text, at least for now. We may be adding more modalities later, but we add that in there. So you say like, oh, this is a game about this and that, and you want to make sure that you keep an eye on these rules. And if this happens, you definitely want to let us know because that's not, according to the rules. And then the other big part where we do some game-specific tweaking is for what we call, or what is called, I guess, the perceptual part of the problem. So that's just being able to see, what the heck is happening on the screen, where's it happening, and when is it happening, and being able to do that fast enough. So we still train our own models, but where we used to train it, back on the real paradigm, it was like much more on the behavioral side. A lot of our training now goes in on just being able to see and act accurately inside of these games.
Yeah.
Yeah.
It's interesting to point out there that there's really is a role for like multiple different models, at different sizes, right? We have like, there's the large models that need to do all this reasoning, and then you have the models that you can tune for very specific circumstances. It's a kind of an intricate game, latency, cost, and so on.
So talking about how you guys are integrating it now, what technical breakthroughs, outside of just the general LLM stuff that's been going on the last year or two, made this sort of vision-based approach like doable for you guys? Obviously you said, Julian, you mentioned like maybe within the last year, maybe within the last 2 years, was this even a doable approach? What is it specifically that made this doable? Is it computer vision stuff? Was it the LLMs? What kind of tech made this doable?
I think them coming together. So the video language models or multimodal models. So the large models from the leading providers, including, of course, OpenAI and Google, so Gemini, and also a bunch of open source models like Qwen. They are like natively multimodal. They can take images in as well as text, and images and text, and combine that. So that gives us reason, because you have to think about it as they have seen so much, essentially, so they can recognize so much, and you can do some kind of visual reasoning by combining the text and the input. Now it has downside as well. One of them is that they're slow, right? If you got to send your query over the network to one of these large models, it's going to take time. So you're not going to be able to act within a second. You're most likely going to take several seconds to act, which is why you may want to combine this interspersed with local models that are fast models you can run locally, and that respond in much less than a second, and also use the models that are pure vision models to identify and locate various objects. So here's like this is a complex dance and a complex orchestration. Another issue is that these large models, and this is December 25, and I'm saying this, and it's true now, it might be different. They are in general very good at recognizing things and also even understanding relationships between things, but they are weirdly bad at spatial reasoning. Things that's like, here is a carrot and here is a flashlight, and the flash is under a table, and basically how do you need to move the carrot to put it on top of the table, and these things, it often just fails. It's like it knows about objects, knows what they are and so on, but can't figure out how things relate in space. And then you need to sort of basically get around that by orchestrating smaller models to locate things, and maybe sort of have like a separate little pathfinding routine and so on. So here's where it's like the devil is in the details, really.
And I think, like, following up on what you were saying, Julian, like 9 out of 10 times, or even more often, kind of like the high level plan that you're going to get from some of these models, if you orchestrate them correctly and give them the right information from the game, it's just going to be super reasonable. Like that part like works really well if you put it well together. But then, like you're saying, making a timely decision and understanding where things are, that's usually where you have to do a little bit of extra work, in order to make that work well.
It's not at all obvious to a person who's not working a lot with these models what they're good at and what they're not good at. That's the kind of jagged frontier thing, right?
Yeah. And I think another thing that that's worthwhile kind of like pointing out is where you can gain a lot is by also, like, especially this has really come through this year, but if you can orchestrate the different models, not just in terms of like, oh, I got to call that one or I got to call that one. That's important, right? But the other thing that you can do is that you can crystallize artifacts out of the models that you can then use really quickly later. And so what do I mean about that? That's with that, I mean that instead of like having to use an LLM every time you have to make a decision, you can use an LLM to generate a little piece of code that can do that every time from the outside of the game. But instead of like querying a model, you're just running something that you know is going to work, right? Or if you need to be able to recognize something inside of the game, rather than asking a super big VLM every time. Maybe you ask it, 20,000 times ahead of time, and then you store it in something else, and then you use kind of like this cached response to improve the performance when you need to perform kind of like at runtime. But that's also, the way that we build our models and data sets for stuff is kind of like based on both before we're playing the game and when we're playing the game and after we're playing the game. We're sending all this information around, for different visual models and only textual models, and we pull it back in and we train something. And that's also something that's only really like come together this year, I would say, at least for us anyway. So,
Do you guys think then that maybe the next big advance, based off of what you're saying, Julian, about spatial reasoning and things like that, and just the ability for the models to learn off the games, that world models could be the next big leap in terms of this tech, or is it something else you think?
Great question. And I wish I had like the simple answer. World models simply mean very different things to very different people. I mean, there's a tech which is like such a Genie 3 where you basically simulate kind of 3D. You basically simulating. It produces walking simulators in fanciful environments for you. That's a way of putting it. The issue with it, there's several issues with it. One is that it's slow, and others it's unreliable, and so on. But even if you assume that you can get around this, you get them coherent, you get them like promptable and controllable and fast and all this kind of thing. Then you have the issue that they are making very strong assumptions on the world. Then we get back to what kind of games are we playing. So world model, like nothing you can produce in Genie 3 has anything like the dynamics you get in Candy Crush. So then you need a world model. Then you can imagine, like, can we get a world model of things that are vaguely like matching tile games? In this world we get Bejeweled and Tetris and Candy Crush and Dr. Mario, whatever. But that's a completely different problem. I mean, and now I feel I'm putting on my researcher hat here, as in like I want to do this, I want to build this. This motivates me, but I think that's pretty far from being useful for what we're building at Model. We need something simpler. When we need models to understand that if an object moves to the left, then it will be to the left of where it was before, and things like this. I mean that's the level. And it's like, again, if you don't play around with a lot of these models, it's kind of like it's really hard to sort of see the relative capabilities, where like they can be amazing at figuring out, like you can get a lyrical description of the background scenery you're in, and like intricate, in detail sort of description of like the objects and what they could be used for and so on. But then it still can't understand that it needs to move left to go left or something.
But well then, I mean, going back to how it actually is used in practice in the current products and things like that, how do the actual game studios integrate it? We touched on it lightly, but they're not integrating it in the code level, right? So what do they do, assuming it's a genre that you guys are working with?
Yeah, I mean, currently the way that we work with and have worked with our early customers is that we ask people to point us to their App Store build if the game is already live, and then we're going to show us first results with that in the first meeting. And that's kind of like a neat thing about this black box approach. You can show up and say like, okay, this is what we were able to do with your game, kind of like out of the box, and that's what integration looks like. It's uploading your binary. And then we take it and we run it in our infrastructure with the agents, and we get results out of that. And most of the results are derived from, the video of the game playing and whatever logs that we can pull from the outside. So you don't have to do anything special. I mean, for some games, you maybe want to set up a particular user account, or if you have, some hard and soft currency systems going on, maybe you want to have some tests where it's great to have like a million billion joules that you can just like spend as you're testing the game. But it aligns much closer to the practices that QA teams are used to having when we're setting stuff up for testing it. You also have to produce some text that tells you what the agent should do. So the agent that plays the game. And in that case, you can probably start from the test cases that you have already, or you can come up with some that align with it. And we've kind of like come up with our own version of it. We call them tasks. but at the end of the day, it aligns, alongside either kind of like you can have a task that's like a high level description of something that you want tested, and that could be like, oh, make sure all my menus work, but don't go to the store, or vice versa. Make sure the store works, but don't spend time on the settings menu. Or it can be kind of like very specific, lists of sequences and of stuff that you want to have, and kind of like anything in between.
Well, then, having this easier integration, obviously, like, it's great that you guys can do stuff ahead of time, and that enables a lot of like accessibility. I'm kind of curious then on the output side and on the capability side, what is this newer approach, with the vision-based approach versus the code integration approach? What does that enable? And what is that maybe stronger at in the QA side than the code integrated approach, which I imagine also has some advantages as well. Like, what does this enable? What does this let people do that they just couldn't do before?
Yeah. Yeah, maybe I can start at least, but feel free to jump in, Julian. I guess we could start with the strengths, and I think this is, at least from our perspective, and something that we see that studios and people working on the games find very appealing, is that there's ecological validity to it. So the results that you're going to get out of testing your game with this technology are going to be very close to what you would be getting if you would just hand it off, a phone or the device to a human tester and ask them to play the game. So there's sort of, yeah, go for it, Julian. Sorry.
No. I'm just saying that it's like, just like the wider view is like it's a common problem, but like when you use various game playing algorithms that you might get good game playing behavior that is not human-like. I mean, it's like common from like chess and Go and so on. We've seen this in top level play and like ways to do some weird things, and we've also seen this a lot with like this discussion about reward hacking in learning to play video games, where they learn really strange strategies through reinforcement learning. But here, because basically, I mean, the autoregressive training of large language models isn't exactly, you can't really call it supervised, or you can't really call it like imitation learning, but the way they understand it, it's more, the VLMs understand it's more like what humans would do it, and the kind of action suggestions you get is more like humans doing it, humans come up with, because they're trained on human data. So that is largely why it is true what Christoffer says, that it's more human-like behavior. Although now when I think about it, I'm not entirely sure that this completely explains it. It's empirically true though, that it gets more human-like than you would get with, for example, a search algorithm.
Well, actually, I wasn't talking about the agent behavior. I was talking about the game itself. But you're absolutely right. But I was kind of like thinking that the thing that actually gets tested, the artifact that gets tested, has not been modified to support the agent.
Right.
In any way, right?
It's true.
Yeah.
Nice. But what I said was also true, right?
Yes. Yeah. I agree with that.
This is the we're gonna, after the podcast, we got to get back to this and try to sort of.
I'm curious though, does it ever actually watch players play to learn anything about how to play as well?
We don't do it at the moment for anything that we're selling to. We're getting stuff
for other games.
Yeah.
And we have like a whole pipeline for it and so on. But right now we're trying to go to do away with it, or like to not use it when we don't need to, because that's essentially integration time.
Right. I'm just curious if that could be useful to generate more human-like behavior in certain situations where maybe the LM or AI doesn't really do that normally.
Yeah, no, it could definitely be useful for that. Sorry, Johnny, go ahead.
Although right now, good behavior is more important than human-like behavior for most games.
Yeah.
I mean, and that's actually like there's like three different things. It's like playing a game well, playing a game human-like, and also playing in a game in a sense in a way that's useful for testing. Because the testing, you're often sure you need to be able to play the game, you need to go through it, but you also want coverage, and that is slightly different. But yeah, it can definitely help to train on human behavior for the particular game. But if we can do without it, it's preferable.
Can you actually tell the AI, since you say you can kind of communicate with it, can you tell it to purposely try and break the game, to do things that like a bad actor would do in the game? I don't try and play the game well. Try and screw it up. Try and do things that you shouldn't. Try and break the game as much as possible.
Oh yeah, definitely. Like a lot of the tasks that end up getting entered into our system go in that direction because you want to be testing for some of those edge cases, or you just want to make sure, you want to make sure that everything works. We've also, we give the agents full OS level access. So if it's like on an Android phone, it can use the keyboard and it can, it could go to a different app and then go to Play Store or whatever. So, we've also had it rename itself and, try to change the account password and stuff like that. And obviously you could put some guardrails around it, right? But all of that is available kind of like by design, but because you want to see what happens when the agent, turns off the internet to the game mid-session, right?
Nice. Well, yeah, definitely helpful. You mentioned earlier about like this something being something more accessible for non-technical people as well, and maybe even non-QA people. Do you see this expanding out within companies and things like that? The sort of QA role or the ability to do QA stuff. Say for example, right when you're developing the game and you're one of the coders on it, it's very helpful to be able to then run the code that you just built and test and make sure that thing works before sending it to QA. Is this something where you like increase the accessibility of QA processes to other people, and what do you see that what direction do you see that going in terms of helpfulness for companies?
We'd love to be enabling that way across different disciplines. I will say what we're putting out there has, the QA folk in mind. So like the typical user for us, kind of like North Star is like serving a QA specialist or a QA manager. But there's no reason that other disciplines can't like pick this up and use it for, you could be interested as a designer in like how often does something occur perhaps, or like you were saying, if you're like an engineer in the game, you want to make sure that we spend a lot of time in this part of the game. And any, if you have anyone with an account on our platform could do that, I suppose. You're not limited to being on the QA team necessarily.
Well, Julian, going to you for more between practical and ethical question is how you draw that sort of line between like augmenting what humans are doing, the quote unquote giving them superpowers, and the replacing human part, which I think is, especially in the QA department, but a bit of a big concern, with unionization and things like that going on. So I imagine that's something on people's minds listening to this. Like where do you see that landing, especially with your product, but also just the general concept of using AI in QA?
Honestly, it's something that we think a lot about, and it's something that, also outside of QA. So when we went for QA originally, one of the reasons was that we thought that this was one of the fields where people were less worried about being essentially replaced because fewer people take that kind of, see it as a domain of their own creative expression, right? But then again, it's a job. And trying to take away people's jobs is not something to be done without serious thought, basically applied to it. So what we want to do is basically to give people leverage to basically be more effective testers and more effective at QA. Now, and you could argue that, okay, if the machine does all the QA, what would human do? No, but human sits on top of it. And here's the crucial thing, though. Almost all games are nowhere near tested enough. We need way more QA. We just don't have the resources. So what we see as what we're doing is that we're basically giving testers superpower. Like basically, instead of like playing this kind of repetitive sequence 100 times, you're basically telling 100 agents to go around and go and do it and report back to you afterwards. And then you need to do this every time someone changes something in the game. Well, you just click this button and there you go. And instead you spend your time basically doing high level analysis of the results and also thinking about what should be tested. Like basically we're seeing this in other kind of AI augmented field, like, the cognitive work moves more into deciding what should be done. Like when you're kind of using AI tools to program for you, it comes more in like what should be implemented and so on.
And if I can add to that, Julian, I actually think, from my perspective, you do need a lot of creativity to do like good QA. And hopefully this could kind of like enable you to unlock more of that. Because a lot of the, like, yes, you have to do like a bunch of repetitive and you have to test when everything works and you have to go to all the parts of the level and all that stuff, right? But the kind of like underlying that, one should also remember that you need a lot of kind of like lateral thinking and the kind of like creative, holistic systems understanding, both to figure out like, where do I go to break this system? What have I seen and haven't I seen? And so that is the thing that I imagine the human operator would be spending more time on, right? And then also kind of like diagnosing things. So rather than having to collect all the evidence yourself, like through, by playing the game, you get handed like, kind of like a detective mystery case, and you start putting those, different clues together out of the gate. And that's part of our vision with it anyway.
So, I mean, how far can this go in terms of acting like a real QA tester in the reporting side of things, right? You talk about, the sort of QA person started deploying these like a bunch of workers and bringing information back, but how far does that information go? Like, can it actually identify like reproduction steps? Here's how you would reproduce it. Here's a video of it. Here's like sort of the root cause, we think, or is that left more to the human side of things of like, hey, I found bugs. You figure out how this all works off like a recording or something like that.
I would say some of it we pull together for the user already. So if you give us a list of steps, the system will check for all of those different things happening. If something different happens, it will tell you what happened. We're also increasingly working on pulling together multimodal bits of information. So we take the video and we take the instructions, we take all the thinking that the agent had, and then also, the game log, if we can access it, and anything that happened on the device. And then we can like make all of those available in the reporting, and we try and use that to pinpoint the different moments that a human expert human tester would want to know about, and then summarize it. So it's kind of like in two levels. We have like all the individual indicators, like here we saw something happen this minute, go to this video, you can correlate it to the log, and we had a performance spike. And then we start looking for patterns in all of us, and we pull them together in kind of like, high level reports for the user. And then sort of like on from there, deciding what happens next. That's where we currently say that's where the human expertise comes in, and you decide what flies and what doesn't fly, what gets sent on and what doesn't. Of course, it'd be super interesting in time, and I think eventually it will be feasible to take some of these like higher level summaries and then say, oh, actually, in 9 out of 10 cases, this is the typical fix for an issue like this, and here's a post that goes along with it. Maybe you want to send that to the dev team, and maybe you want to send it off to some other AI agent that could make a pull request to your repo, and then somebody could decide if that's what we want to do.
So how do you see this fitting in then with other AI tools? Like, so for example, on the report writing side, right? Like maybe, there's a human involved in identifying a bunch of stuff and collecting that information, but then AI writing the report or dealing with tickets. Like, how do you see this fitting into the broader ecosystem as people look for different places and different ways to integrate AI? And it's almost sort of like idea of AI coworkers, where there's people with sort of different AI departments handling different aspects of it. Where does this all fit in?
Yeah, I think this is a process step that kind of like was missing before. But, on one side of this, we have kind of like the CI practices and producing the artifact that gets tested in the first place. And that has to go together with the tools that people are using already with their testing expertise to decide what actually get tested on this kind of artifact. And you've got, our system in the middle, right? But the output is also information that then needs to go to Jira, where people might review it, or it goes to some documentation system, or it goes straight to the code repository. But I think it's key for a solution like this that it's like super interoperable with all the other systems that people use and that they might want to connect to this. Like we don't see any reason for, like, once you've run a test with us and you've executed your game and the agent did things and we collected data about your game, and we make conclusions off of that. A product like ours should just make that available for all the other places where it would be helpful for you to plug it in, because at the end of the day, it's kind of like about maximizing the leverage that this automation gives you, and then let people do as much as they can with it.
Imagine this going really far, like in different ways. Maybe one day we'll have a command line interface. There's Cloud Code and model, test sort of
Right.
CLI.
Where it sort of integrates into that sort of broader AI environment, so to speak.
Yeah. I mean, we'd love for this to be like, imagine if this generates an ongoing knowledge base about the history of your game and where your game is now, and you can actually query that down right into that. You can ask, oh, is level 6 broken, right? And then the system comes back and tells you, oh, these are the reasons that I think level 6 is broken. And now you might become more interested. And then you say, okay, how long does it take you to complete level 6 on average? And then you start using that data in interesting ways, right? Now, if you have something that's playing your game all the time, you collect so much information about it, right? And so you could imagine just like asking questions straight down into that and getting, information back that you can use.
And you can look at what the tests you've done in the past and saying, hey, I saw you did these tests on level 6 before. Like, should you do this? You want me to basically run those again and do slight variations and stuff like this. And while you're anyway doing something else, have it running. Yeah, this is like, since the very beginning of Model, we've had this vision that like, you should, as you're developing, there should be agents playing your game all the time, keeping the servers warm and feeding data to you. This also comes out of like academic prototypes of this we did way in the past, basically. So it's like, real-time agents playing.
Yeah, I guess I'm curious where you see the management side of this going. Like, because right now, you're talking about, oh, this is kind of deployed by maybe the QA team leads or some of the maybe more experienced QA testers who kind of know how to direct what kind of testing to do. But do you see this going pretty easily into a QA agent manager that's AI managing the other QA agents that are AI to like you said, run that 24/7, where it's like, hey, we're off for the weekend. But this AI over the weekend is just sitting there managing itself, directing different tasks, knowing which coverage needs to be done, or figuring out additional coverage, checking in tests. Like, I could see, obviously, there's a lot of potential for orchestration to be pretty huge in this. Do you guys see like potential to grow this, for example, this product out to that, or to integrate maybe with other products that help manage that, as we kind of touched on a little bit earlier?
Yeah. I think there's a lot of, and maybe that isn't even the end game, but that's kind of like a place where you could end up through something like with this, right? With something that's continuously generating new knowledge about your game. And then again, we're not limited to just finding bugs off of it or kind of like, concrete issues that would need to be addressed. You could also use this for balancing information or personalization information or assessing what would be good for different player groups. Like suddenly the possibility space expands a lot from being find issues to, so not just talking about, whether it works, but kind of like what works well and what like aligns with the vision that we have. And you start giving people design relevant information kind of like up and down that axis, if you think about it that way.
Cool. A lot of fun possibilities, I imagine. Julian, then, given how much has changed in the last year, 2 years, I mean, I guess all the time really, but especially in the last couple of years, what do you see happening in, say, the next 2 years from sort of the technology standpoint that affects all of this, whether that be like specifically your product or just QA sort of testing in general? Might even be outside of games, but just general sort of QA testing that's possible with this tech and next level tech. It doesn't sound like world models probably within the next 2 years will be super useful, but what else might be?
You were saying before the end game, just like, and I was just thinking, the end game. There is no end game. There was a Marvel movie called The End Game, and then they just kept coming out with movies afterwards. They just kept getting more and more confusing, It's like
both of this are movies here. I would like for this to not go the direction of the MCU. Let's hope it's more positive than that.
It's I mean, the spatial reasoning thing, obviously, on the technical side, is a really big thing. Then there's something as simple as speed. I mean, speed is a real issue for us right now. Like we constantly navigating the trade-off between analysis quality, reasoning quality, and speed. And the more that solves itself, the better results are going to be. There's at some point going to be a test, a cost issue as well, but this goes hand in hand with the speed, essentially. Wow, this sounds really, really boring. I'm just like, you're asking for this visionary stuff. I'm just like talking speed and cost and, but honestly, these are major issues for you, for us. And there's a lot of stuff we could do in theory that just doesn't fit in a production workflow because speed and cost. And we are really excited about like what we could learn across games. So as we said before, all the games are different, but within the genres in particular, things that could generalize, and questions such as if you learn something about testing strategies for match 3 games? Will it carry over to merge type games or like falling blocks type games and so on? And can we use that to basically suggest interesting actions and so on? Then another thing that, again, looking at a very rich literature of things that have been tried in academia, but like are far from like applicable in production so far. Can we look at player styles? Can we have this levels tested by played in a lot of different playing styles? Like here's different player archetypes. Which kind of issues would be faced by a pro player or versus like an amateur? And of course, like going beyond, does it work or not? Like giving like complete experience reports of the games. Like, hey, I played this part of content you're proposing here, and I think this is going to be interesting for like novice players, but kind of frankly a bit boring for pro players. So like, hey, I played this, and I think there are too many options. A few people are going to explore these things. Like, there's so many things you can go into here, and then being able to even like what kind of behaviors would happen, what kind of players would be attracted to this, for example. At some point, there is the, and this is this isn't, I'm taking off my academic hat, because you might get dirty. Then you have to connect this to ad monetization. Can you use this playthrough data to predict which ads should be shown or which ads you should show? What kind of players you want to attract through understanding the game through automatic playthrough analysis? Almost certainly you can. And if you are the company doing all this testing, then you'll be sitting on a lot of like data about like game playthrough profiles and what player archetypes will work and will not work, and then you could use that to do interesting recommendations about, for example, ad placements and ad buying. And maybe I'm saying too much now. Christoffer, tell me if I should. No.
I think Ben's about it right in here.
Well, yeah, it's really interesting to think about that idea of an AI focus group, like QA testing for subjective instead of objective problems.
Yes.
No, but obviously, it's like this thing, like, does it work and does it have obvious bugs? Is really, really just scratching the surface of everything you can get through playthrough analysis. And again, like, people who want to second guess us and figure out the next moves can dig into the many dozens of papers we have in our academic selves written about the topics.
Plenty more additional research.
This is like a whole heap of ideas there, like, that we just barely got working for one simple prototype game, but like, currently is far from working in a generalizable way in any kind of production environment. But we know that in principle it can be done.
Well, cool. Well, hopefully it'll be possible.
And of course, there's the more direct integration into content pipelines. Like, okay, I see that level 6, because we were talking a lot about level 6 today.
So best level so far.
Level 6 doesn't have good content for like for exploration focused players. Do you want me to suggest this kind of labyrinth puzzle here, and so on?
It's gonna be like ChatGPT at the end, always suggesting, like, you want me to make a table of that? You want me to make some slides for you?
Yeah.
Exactly, which is like, so I'm thinking more visually. It just pops up like, hey, how about this puzzle here? Do you want to put this here?
Okay, so we like to finish things off here with just a few quick questions, just to get some quick bites for fun. So feel free to be a little controversial if you'd like, but we're just gonna go through the 3 questions real quick. And the first one, just kind of an example you can give of an unexpected success or like an emergent behavior or something from using AI and QA that's just like, well, what just happened?
Well, the overall unexpected success is that it works as well as it does. Like, who would have thought that? But like one thing we saw recently was an agent that entirely failed to follow our instructions. And by doing so, showed it exposed a massive bug in our system, and then at the same time triggered a bug in the customer's game as well. So I think in many ways their bug showed us our bug, and our bug showed them their bug, and we weren't really counting on that. So the question is like, who's really testing who?
Cool. Good answer there. What areas, and I know you mentioned the jaggedness earlier, do you still see AI unexpectedly struggling outside of just like the genre thing?
Sure. I think I'm always surprised what they can remember and what they can't, especially for kind of like long running or long horizon tasks. They'll remember really arcane and unexpected things, and then they'll, forget whether red means on or off for a button. And you kind of like have to work about around both of those things. So, smart, but maybe not necessarily smart in that way.
Some coherency issues seems to be a constant thing with these. The more complicated they get, the shorter the memory seems to be. So that makes sense. And this, feel
The
free.
better off they are.
Yeah. Feel free to get a little controversial on this one as well. Some shots fired moments if you like. But any recent games that you've seen that really could have benefited from some AI QA coverage?
Oh, I don't want to call. So what I actually have seen are some games that have been out for a decade that could still benefit from some QA coverage. So I think nobody goes free here. You can get a title that's been in live ops for half a decade, and you'll still find stuff in there that people either know about or even didn't. So I think we're all in this picture, and we have to decide if we like it.
Maybe you'll have to get some people to use it for remasters, right? So when they go to remaster the game and know about a lot of issues, they can make sure they get some good coverage there and have the remaster be a better version.
No, that's right. We'll test both, and then if you want, we can compare which one had fewer or more bugs in them. Yeah, that's we'll do that one for free.
Cool. Well, hopefully it leads to better games, right? That's what this is all about. Hopefully at the end of the day, as your product grows, as other products go, either just the whole AI ecosystem grows, it leads to better games and not hopefully worse games. But I think there's definitely some positive future here. And it's great to hear what you guys have cooking. I imagine a lot more cooking under the hood that we'll see over time here. So if for anyone who wants to check it out, it's Modl.ai, but no E in there. So just Modl.ai. Of course, be linked to the show notes. But for those of you who are just listening, I want to make sure people know where to find you guys. Lots of cool stuff. Lots of great to see the technology be unlocked as well from these new changes in vision. So, but I want to thank you guys for joining us for the second time for you, Christoffer, first time for you, Julian. Really appreciate the conversation. A lot of fun stuff in here. I'm sure we could keep going forever as this tech is continuing to emerge. But I want to thank everyone listening as well. Hopefully you had a good time. It sounds like Julian is suggesting there's a lot of reading material out there for those of you who want to go further down this rabbit hole.
Oh,
So
let's come.
What's the fun stuff? Or have AI help read it for you. Yeah. So it's like, so. But
but then you'll have to curate the app AI servers to see what it missed.
Comprehension tests. Let's see. Cool. Well, thanks, guys. And we'll catch everyone on the next episode. In the meantime, have a good one.
If you enjoyed today's episode, whether on YouTube or your favorite podcast app, make sure to like, subscribe, comment, or give a 5-star review. And if you want to reach out or provide feedback, shoot us a note at podcast@naavik.co or find us on Twitter and LinkedIn. Plus, if you want to learn more about what Naavik has to offer, make sure to check out our website, www.naavik.co. There, you can sign up for the #1 games industry newsletter, Naavik Digest, or contact us to learn about our wide-ranging consulting and advisory services. Again, that is www.naavik.co. Thanks for listening, and we'll catch you in the next episode.